For almost 90 years, ESB has gladly accepted its role as a leader in innovation and technology and has understood the importance of leadership by example. The proposed new building for Fitzwilliam Street will focus and enable the company's performance as both a driver of progress in Ireland and responsible corporate citizen.
The building we're in at the moment it's an old, it's a pretty tired building, it's not sustainable, and this is an opportunity for ESB to show real leadership in the area of developing the future workspaces in this part of Dublin.
Even with that, it's still 300 mil above.
Sustainability and green solutions are very important for ESB. In fact, they should be important for all power companies, given the impact that our activities have on the environment. And our ambition is to build a building here that is truly exemplar in sustainability terms.
This building has a lot of things which are interesting.
I'm excited about the new building, and I think it's really important for that head office building to be in many ways a showcase. It can be pointed to as a real concrete example of how the company is very much committed to innovation, committed to sustainability. So I think there's a really powerful alignment of objectives between the design team and the project team and ESB's sustainability ambitions.
The ESB would like this to be a world-class sustainable building. They would like it to demonstrate that it's possible to produce buildings with a much lower environmental impact. But they'd also like to do it while showing that this can be done in an economic way.
Could actually become, in the next slide, we're really talking about...
It has literally come from the ground up in terms of this design proposal, from the type of materials that we use, the layout of the spaces, the floor plates themselves, and the engineering solutions for the project.
First thing to consider when designing on a city centre site with regard to sustainability, when you're designing an office building, is to make sure that the office building has sufficient light and air. So the actual massing of the building itself, the way that it's put together on the site, leaves sufficient space between offices so that we get maximised daylight and maximised ventilation.
The biggest energy use in an office building is air conditioning, and if we can remove or reduce the amount of air conditioning used, then the energy usage can be reduced. In the ESB building, the ESB use a special type of computing which is called thin client computing, and that removes the computing power from the space into an external space. We're also looking at using LED lighting. LED lighting uses up to 50% of the energy use of traditional lighting, and that also reduces the heat into the space. So getting the heat out of the space means that we can operate in a natural ventilation mode for a longer amount of time.
We really wanted to create floor plates that were sustainable by nature, in terms of that people could actually open the windows, that there was natural ventilation across the office spaces. People were in control of their own environments.
Then when it becomes really cold outside, the mechanical ventilation system turns on. And the reason it does this is so that we can recover heat from the exhaust air. If it's -2 outside and it's 20 degrees inside, we're dumping this hot air and we can recover the excess heat from it.
In this proposal, we're going to have a ground loop water system which is going to take heat from aquifers deep under the ground, and this is effectively free heating and cooling that we can use to supplement the systems that we have in the building.
The heat pump systems in the building are quite interesting. We're using a combination of a ground loop system and an air source system. The transferring of heat is much more efficient than the generating of heat. We're using each system when it is at its most efficient.
Very briefly, all these different aspects of how we manage the building. From the beginning, the ESB set out that the building should be BREEAM excellent. So we wanted to have something that showed how electricity could be used very, very energy efficiently, and minimise the use of electricity within the building. And also to show, I suppose, or to showcase different technologies.
We're going to be storing energy in the form of ice. Now, ice allows us to store cooling potential. During the day, we will use the ice to cool the building. This allows us to smooth out the electrical load and the electrical demand on the grid, which helps support Ireland's policy of adding renewables to the grid.
The building is being designed so that 80% of the time the building won't require any additional energy for heating and cooling.
Is that in Georgian architecture, it wasn't just the brick and it wasn't just the facade, it was also that gardens were really important. So
the ambitions are to make it as green as possible, if that's not a hackneyed phrase, to make it as environmentally worthwhile as possible, but to also make it very beautiful.
We are trying to almost green the building. We've used a lot of landscape and broken down the massing of the buildings so it doesn't feel like one large office block.
This building should use about 70% less water than a typical office, and that's achieved in a number of ways. The first is by reducing the amount of water demand by using special fittings that use less water. The second is by recovering rainwater from the roof, so the rainwater that falls on the roof is stored and then recycled for use in toilet flushing. And the third is the recovery of groundwater from below the site. We're very lucky in that just directly below the site there's a huge supply of water which we can draw up and use for toilet flushing and for watering the landscape.
The building's footprint is lessened by all of these things, but more importantly it means, can the landscape function as some component of engineering? Dublin has a problem with its drainage like most cities, in that the drainage is at capacity, and when we have a flood event, the water system is overflowing. But if we can reduce the amount of water that the building is casting into that, we're doing a good job. So the top roofs, with that natural planting, will act like a sponge, holding the rainfall after heavy rainfall events and gradually letting it drip out when capacity has been restored in the system.
We're very much, I suppose, using sustainable solutions, using renewable resources that are available within a very tight city site, and also, I suppose, creating what we hope is a sustainable lifestyle for the workforce in terms of distances from windows for their workplace, encourage them to cycle to work.
25% of our people walk or cycle to work. Another almost 50% get public transport. So for us, being in this location is extremely sustainable. This is something which is not just a goal, it'll be something people will experience, and therefore people will have a sense and a feel of the energy and of working with the environment in this new building.